In this video, we will be covering vectors. Vectors are one of those topics where students often just memorize formulas, but don't actually understand what the vector represents. I'm going to explain to you guys what a vector really is so you can get a strong conceptual understanding moving forward. First, let's compare a scalar to a vector. Let's say we have a stick, okay? And this stick is going to be 5 meters in length. Then we have another stick that looks like this. And it's also 5 meters in length. These sticks, if they're scalars, are indeed equal because their scalar value is 5 meters. The vector, on the other hand, if I were to draw these same looking sticks, but as a vector now, okay, these are no longer equal because a vector cares about two things. It cares about the magnitude and the direction. Okay? On the other hand, a scalar only cares about the magnitude. The magnitude is like the distance. It's just a more proper name in mathematics. So that's the key difference between a vector and a scalar. So moving on, let's look at some notation for a vector. So to write a vector, you could do it in a few ways, but most typical way is with a variable and an arrow on top of it. So this would be vector v. You could also write it like this. You could write it like this. That's right. There's a few ways to draw the arrow, but generally it's a variable with an arrow over it. So let's just work with vector v. So vector v will consist of two components, component A and component B. Component A is your horizontal movement, and component B is your vertical movement, or you could say X and Y movements. So if we put these on a grid, okay, and we put this as our y-axis and this is our x-axis. Let's do an example. Let's say vector A was 2, 3. Well, we'd move 2 over and we'd move 3 upwards. So it'd be about here. So this is what vector A would look like on a graph. Let's see what you can do with it. Well, one of the most important things is the magnitude, and I want to explain how you actually get it. So as you guys are probably familiar with, you have something called the Pythagorean theorem, which is a squared plus b squared equals c squared. Well, in this case, this value is 2 because we moved 2 over on the x-axis, and this dotted value is 3 because we moved 3 up. So bringing out this triangle over here, it really just looks like this. A, 2, 3. And if you see something familiar, this is actually right triangle, so we can apply Pythagorean theorem. Well, we want to find the length or the magnitude of A. So to calculate that, let's rearrange our formula here and square both sides. So we get C equals the root of A squared plus B squared. And this is exactly the magnitude formula. So now if we plug in our A and our B, we will simply get back the magnitude of A. So we'll plug in vector A for C, by the way, because we're not working with C, we're working with vector A. This is our C. So we'll do root 2 squared plus 3 squared, which equals root 4 plus 9, which equals root 13. So that is the magnitude of vector A. So now let's take a look at adding and subtracting vectors. Let's take two example vectors, which is vector A, which is going to be 2 and 3, and vector B, which is going to be 4 and -1. Well, adding them seems pretty straightforward, which it is, and you simply just add your A values. So it would be 2 plus 4 is 6, and then you add your B values, 3 and -1, which is going to be 2. But I want you guys to understand what this looks like graphically. So graphically, if I were to write out vector A again, we have 2 and 1, 2, 3 upwards. Okay, there's vector A. And then for vector B, it's going to be 4 over, so 3, 4, and 1 down. So it's going to be about here. Okay, so, well, how do we add them? What does that look like on a graph? Well, there's something called tip to tail, which is how you add. So what you do is you take your vector B, and you can do it, you could add vector A to vector B or vector B to vector A. It'll be the same thing because addition is commutative. But if we take our vector and we place the tail of vector B onto the tip of vector A, so just the arrow of vector A, this resulting vector from the origin to the tip of the second vector, this is vector A plus B. And let's just check our work on that. Well, we just calculated that the resulting vector is 6, 2. So let's go 1, 2, 3, 4, 5, 6. That's exactly where this is on 6. So that's good. And then we need to check that it's 2 upwards. So then 1, 2. And that is indeed where this is. So as you can see, to add 2 vectors on a graph, you simply add vector B to the tip of vector A by putting its tail against it. So that's what addition looks like. And now let's do some subtraction. Subtraction is actually very similar to addition, so I want to do it with the exact same vectors. So first let's write out vector A minus vector B. And this again is going to equal, we take our first variable, so we do 2 minus 4. So let me actually just show this. 2 minus 4, then the second one is going to be 3 minus minus 1. So 3 minus negative 1. Okay, and if you simplify this, well, 2 minus 4 is just negative 2. And 3 minus minus 1 is the same as 3 plus 1, so it's 4. Well, pretty straightforward, but what does that look like graphically? Well, again, let's draw our axes here. Okay, and what we're going to do is first let's write out our 2, 3 again. So 2 over, 3 upwards is going to be about here, let's say. Okay, and then we're going to go 4 over and 1 downwards, so it's going to be about here. Okay, so here's our 2 vectors. Well, how do we subtract it? Let me label these vectors. And in order to subtract 2 vectors, what you have to do is you have to realize, so let me take a very simple example, totally unrelated to vectors. Let's look at a number. If I had the number 2, and I wanted to make it negative 2, well, how would I do that? Well, what I would do is I would write a number line. You don't realize you're doing this every time, but this is what you're doing. You're going negative 2, negative 1, 0, 1, 2. And if you notice, we started at 2, and all we do is flipping it over the 0, we simply flip the number to the negative, right? You do the exact same thing with vectors. What we just did there with numbers. So what you do is when you have B, for example, all you're doing is flipping the whole vector in order to get negative B, okay? So knowing that analogy, let's look at what we do here. Well, I'm going to take our vector B, okay? And it's a little tricky to do here, but I'm going to mirror it vertically, and then I'm also going to mirror it horizontally. So what I really just did there is all I did was flip it, okay? So look, now it's complete opposite direction of itself, as you can see. Okay, so let's take our B out of here, okay? And let's replace it with our new negative B. So really all you have to do in order to get the negative value of a vector is flip it, okay? So what we did there is we really multiply it by a scalar value of negative 1 to flip the vector. So now how do we actually end up with this negative 2, 4? How do we get that? Well, what you have to do is now we once again do tip to tail. Why? Well, think about it. A minus vector B, this is really just the same as A plus negative vector B, right? So now that we have negative vector B and we have A, we're doing the exact same process as we did with addition, which is tip to tail. So let's go get vector B here, put the tail of B to the tip of A, and our resulting vector, which I'll make very bold here, okay, this big bold vector is indeed A minus B. And let's confirm that. Well, okay, we see right here it's negative 2 and 4. So if we go negative 1, negative 2, then we go 4 upwards, 1, 2, 3, 4. We get to exactly this point. So that is exactly how you solve for subtracting vectors and how you can view it graphically. I'm going to show you one last key concept, and it's scalar multiples. So first, let's do a simple one and multiply vector A by 2. Well, 2A, all you simply have to do is basically multiply this vector by 2 and expand it in. So 2 times 4 is 8. 2 times 5 is 10. So that's exactly what 2A equals. Pretty straightforward, right? Well, then let's look at it graphically. If we had a graph again, okay, and we had the point, let's say this is 4, 5 would be like somewhere up here, okay, and here's our vector, okay. Well, when we multiply it by 2, if you notice, it has the same rise over run. So as we know, it's over 4, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. Well, if we do that, if we plot the 8, 10 vector, let's plot that same 8, 10, okay? It's going to look something like this, okay? If this was 10 and this was 8. And I'm going to show you why. Well, because it's going to be the exact same slope. And the reason for that is because, look, if we go 4 over again, 1, 2, 3, 4, and 5 upwards, 1, 2, 3, 4, 5, we get the exact same slope, right? We have the exact same slope because it's the exact same rise over run. So all you're doing graphically when you multiply by a scalar multiple is stretching that vector in the same direction. These should be the exact same direction, by the way. There's a little gap there. There should be no gap. Exact same direction, just longer. So if we multiply it by 5, well, guess what? 5 times vector A will simply just be the same vector 5 times longer. Okay, its magnitude is going to increase by 5. And that shows you another effect. What's the effect on magnitude? Well, if we calculate the magnitude of A, okay, it's going to be root 16 plus 25, which is root 41. Well, you know what that also is? If we wanted to find the magnitude of 5A, well, we just know it's going to be 5 times root 41, right? It's as simple as that. So this is exactly how a very basic scalar multiple will work, but you can also shrink vectors by dividing them. But when you work with vectors, you don't actually typically divide them. We say we multiply by a fraction. So if we had vector A again, okay, we could multiply vector A by 1/2. And again, simply what that would do is we just take 4, multiply by 1/2, we get 2. 5 multiplied by 1/2, we get 5 over 2. And this will be what 1/2 A looks like. So this is like compressing the vector. And if it's larger than 1, it'll be stretching the vector. There's one more very important one, which we kind of already covered, and that's just negative. If I multiply by a negative scalar, so if I multiplied A by negative 1, right, it's equivalent to multiplying by negative 1. Well, it's simply just going to create -4, -5. We distribute it. It's the same rules. You just distribute this negative amongst your whole vector. And what does this look like graphically? Well, we already covered this. If we had a vector like this, the vector will simply just turn into this. Okay, so this is A, and this is -A. So those are all your key concepts for scalars and how you work with them graphically. So now let's end off with one practice question. So given the point A and the point B, find vector AB, okay, and its magnitude. So if you guys want to pause the video, feel free to try the question yourself. Okay, so how you approach this question is first we need to find vector AB. So to find vector AB, we simply, let me give you guys a look at this graphically again. Let me plot point A. A is going to be 1 over and 2 upwards, so about here. Here's point A. And B is going to be way higher up here, 7 high, 5 over. It's going to be like somewhere up here. This is point B, okay? So now you see point A and point B. To find vector AB, we're simply finding the vector from A to B. So, okay, the vector that looks like this. So B minus A, point B minus A equals vector AB. Okay, so doing that, we're going to have 5, 7. I'm just plugging in point B minus A, which is 1, 2. Let me just show you where I'm getting these from. I'm simply plugging in point B, which is here, which then goes into the equation. And then we have A, which is here, and we're subtracting it. So there's the minus sign, minus vector A. Okay? And the resulting vector will be, we first do 5 minus 1, which is 4, and then 7 minus 2, which is 5. So this is vector AB. So I'd write something like, therefore, AB equals 4, 5. But we need to find one more thing. And what is that? Well, we need to find its magnitude. So to find its magnitude, as we know from the formula previous, the magnitude of a vector, so in this case it's vector AB, equals the root of A squared plus B squared. Well, A in this case is 4, as we just found out from finding our vectors, so root 4 squared, and B is 5, so plus 5 squared. There's going to be root 16 plus 25 once you expand, and this will then equal root 41. So there is your final answer to, so if I were to write one final therefore statement, let's bring this all down here. So the therefore statement will be, therefore AB equals 4, 5, and its magnitude is root 41 units. There is your final answer, and I hope this video helped. So the big idea I want you guys to take away is that vectors are really just movements with direction. Once you understand that, the formulas start to make a lot more sense. So if you're in grade 12 and vectors are starting to feel a little bit confusing, or you just want to get ahead, ClearMark Prep offers group sessions and one-on-one tutoring at clearmarkprep.com. Feel free to check out my website. It's in my bio, and I hope to see you soon. Have a great rest of your day.